Tell me about how HSMs are, and they're everywhere inside financial services. If you really, really have to protect something and the keys for encrypting data around it.
You have to think about how does the online world really operate or work, and how do we make sure that data is secure? How can we trust each other, in the digital world? And this really happens through encryption and digital signature. There are keys involved, encryption keys, signing keys. Ask yourselves, where do these keys come from? Are they secure? Where are they stored? And who has access to it? If it's just in a software system, it can easily get hacked. If I have your encryption key, I can read your data. If I have your Bitcoin keys, I can spend your money. And so it's really important to securely store them, control access, and also generate good keys so they cannot be guessed. And HSMs are the best things for doing that.
So you've got a patent on a multi-authorization system for Bitcoin keys. I like that use case. Tell us about it and what the adoption rate is.
Crypto custody, for Bitcoins or whatever cryptocurrency is actually is a big business for our HSMs. If you think about Bitcoins, it's about money, and it's sometimes about a lot of money. So what we have here is we added security to the normal HSM system. It's like you have a transaction, it's sent to the HSM, and if you have the access credentials for the HSM, it's getting signed. So you need a lot of security there to make sure what's getting sent to the HSM. If you're a bank, you want to have a more secure system, and that's the multi-authorization you mentioned.
Welcome back to the Security Strategist podcast, your blueprint for evolving cybersecurity. My name is Richard Stiennon, and I will be your host for this episode. I am the Chief Research Analyst at IT Harvest, an author and a trusted advisor to vendors, VCs, and private equity firms. Today, I'm talking with Robert Rogenmoser, who is CEO of Securosys, and he will be talking about hardware security modules, HSMs. And this episode will particularly explore why protecting encryption keys is so critical and how the industry is preparing for major shifts from the move to post-quantum cryptography to the rise of cloud-based HSMs and their use cases. We'll also discuss the emerging challenge of securing AI agents. Welcome, Robert.
Thank you, Richard. Great to be here.
Robert, tell us how Securosys came about.
Securosys came about around 11 years ago, here in Switzerland, after I came back from a 17-year journey in Silicon Valley, came back here and started with a friend, Securosys. And as any small company or any startup, after about 3 months, we pivoted to building HSMs because we got a call from the Swiss National Bank, the Swiss Fed. They asked us, can you build an HSM? And, the young fools that we were, after 1 millisecond, we answered, yes, of course. And so we did.
How hard could it be?
How hard could it be? Yeah. Okay. I'm cheating a little bit. I've been 17 years in Silicon Valley. I did big projects, big stuff, My co-founder, Andreas, actually was in the cryptographic business, before. He knows cryptography very well, and he's actually our cryptography brain in everything we're doing, So it wasn't like there are two young kids out of school that doing something and bring up Linux from nowhere, something like that. So we had an idea what we're doing. But for us, it was really a great opportunity because we were building the HSMs for the Swiss financial network, Besides that, we actually got the job, we actually also executed, and more or less 1.5 years later, we delivered the first HSMs to the operators there, to SICK, and ever since, our HSMs are used in the Swiss financial network, and it's a cool reference card, in particular, when you look at the numbers, in the Swiss banking system, every day there is 100 billion in Swiss francs, which is these days about 125 billion US dollars that are transacted through this system every day. And so just for fun, sometimes I don't know what I'm doing, but just for fun, I said, okay, let me think. We did 10 years every year is about 250 days, 100 billion, that's 250 trillion that we protected in financial transactions over the last 10 years. So it's a big number. So,
and too bad you didn't negotiate, a cut of that along the way.
Yeah, let's see. If you're a startup, you have not much power in negotiations. Let's put it that way. So We're quite happy that we had the deal, and we could renew it a couple of years ago for another 10 years. So so we have the next generation devices out and are improving and moving, as you said before, towards post-quantum algorithms and so on.
Tell me about how HSMs are, and they're everywhere inside financial services, right? If you really, really have to protect something and the keys for encrypting data around it, you use, a separate hardware device. But it seems to have universal applications anywhere that you have to keep something secret.
You have to think about how does the online world really operate or work, and how do we make sure that data is secure? How can we trust each other, in the digital world? And this really happens through encryption and digital signature. When you think about encryption and digital signature, it's immediately, there are keys involved, encryption keys, signing keys. And you have to ask yourselves, where do these keys come from? Are they secure? Where are they stored? And who has access to it? If it's just in a software system, it can easily get hacked. If I have your encryption key, I can read your data. If I have your Bitcoin keys, I can spend your money. And so it's really important to securely store them, control access, and also generate good keys so they cannot be guessed. And HSMs are the best things for doing that, hardware security modules. And we believe that the ones from Securosys are the best in the world.
So as many companies move away from physical boxes to so-called HSM services in the cloud, they get convenience with that, right? And they don't have to worry about all the physical security around it. How do you ensure that clients maintain control and multi-authorization capabilities for their keys when it's hosted like that?
Yeah, I mean, that's the trend for, 10 years or more. Everybody moves to the cloud. You don't run your own data centers anymore. And that's definitely also the trend for hardware security modules. And if you go to AWS or to Azure, they have a cloud HSM, they have an Azure Vault, and there are HSMs behind it, that protect keys. We at Securosys decided also to offer a cloud HSM solution, with that. We have different flavors, different layers, from really sandbox systems to try out for free to actually shared environments which were quite economical to full HSMs that people can use. We are having our cloud HSM system across the world. We have sites in the US, 2 sites in the US, 3 sites in Switzerland, 1 more in Germany, and 1 in Singapore. And you can have your keys wherever you want, And the advantage really is if you have your data and your keys with the same cloud provider, the cloud provider has everything of you, which maybe for an American company is not that big a problem, even though I talked to some law officers that really don't like that idea that anybody can access in the AWS system, for example, onto their data. But for European companies, the data sovereignty thing and the data privacy thing is quite big, quite a quick topic. And so you can keep your data encrypted in the cloud while you keep the keys somewhere else where only you have control over it. And because you're the only company or entity that has access to both, you can actually only access the data, not we as Securosys, not the cloud provider.
Got it. Let's talk about post-quantum cryptography. Where it's something that people actually talk about Q Day, I believe, the day that all of a sudden magically quantum computers exist, which may be very, very far in the future. But nevertheless, since we understand the risk, cryptographers have gotten clever about coming up with new algorithms. How does that impact the keying part of it?
Yes, I mean, that's a big topic. It's a big transition that's happening in our industry right now. I mean, the quantum computer is really, people call it the black swan, it may come. We don't know when it comes, if it's tomorrow or in 5 years or in 20 years, but we're not just waiting for it to happen, to come around, and pretty much break any asymmetric cryptography. That's the term, asymmetric cryptography. You lose your private keys, your signing keys are really affected by that. So the great thing is NIST, the National Institute of Standards, started looking at how can we deal with quantum computers, I think 5 or 10 years ago already. They made competitions for new algorithms that cannot be broken by quantum computers. And, over the years, hundreds of algorithms were tested. Most of them fell by the wayside. But end of last year, they certified or released new algorithms, 3 new algorithms. Of course, we already implemented them in our HSMs, and you can actually run cryptography or signature algorithms with this new quantum computer proof algorithms.
Is there a way to ease into being post-quantum ready, I guess, if that's the right term? And so use one of your HSMs and your algorithms to create keys, but not necessarily disrupt the total data structure in your organization?
You have to try out the things. The problem is with these new algorithms, they run maybe longer, especially the SHA-based algorithms, they take more time. They have longer key lengths, suddenly the key that was 1,000 bits or 2,000 bits, is 50 kilobytes, and stuff like that. The signature, which used to be 256 bits, is suddenly kilobytes big, so systems change, and you have to adapt for that. That's one thing. So the thing really what most people do is trying it out. And the other thing is also the existing algorithms, the RSA, ECC algorithms that are used for this, they are not broken yet. There is no quantum computer around that can broken them. So what people really do is they employ a hybrid system. They use both an RSA signature and the new quantum computer ML-Chem signature, for example, and do both, so that both things are protected, On the other hand, what people also worry is this store now, decrypt later scheme, where people store communications or data and expect to break it in 10 years. So you have to think, or whenever the quantum computer is out. And so you have to think what data is in your enterprise these days or in your systems that are relevant or are still top secret in a sense in 10 years, or 20 years, whatever your expectation is for a quantum computer.
Got it. So you've got a patent on a multi-authorization system for Bitcoin keys. I like that use case. Tell us about it and what the adoption rate is.
Crypto custody, for Bitcoins or whatever cryptocurrency is actually one of is a big business for our HSMs. If you think about Bitcoins, it's about money, and it's sometimes about a lot of money. So what we have here is we added security to the normal HSM system. Typically, honestly, an HSM is a pretty simple device if you want to think about it. It's like you have a transaction, it's sent to the HSM, and if you have the access credentials for the HSM, it's getting signed. So you need a lot of security there to make sure what's getting sent to the HSM. If you're a bank and hold a lot of Bitcoins for your customers, you don't want to have just a single person being able to do that, because as we all know, a blockchain operation is a one-way thing. It's you sign a transaction and the money is gone. You know exactly where on the blockchain the money is, but there is no way to reverse it. So if you're a bank, you want to have a more secure system, and that's the multi-authorization you mentioned, So essentially, what you can do with our system is, for example, you can say this transaction can only be signed and sent to the blockchain if 1 out of 3 compliance officers signs this, plus 2 out of 5 traders. And so everybody that is relevant for this transaction, gets an invite to review the transaction and can sign it, for example, with our app here, and approve the transaction. And then all the signatures from the different people come back. The HSM then verifies, do we have a quorum? Did everybody actually sign the same transaction, or did they just sign something? That's another thing. A few zeros more or less. That's a big difference. Mm-hmm. And only then the Bitcoin key, the actual key for the blockchain, is used to sign a transaction and send it to the blockchain. And so you add a lot of more security to your system. This is, of course, you don't want to do this for every transaction, if it's $5, come on. And so we also have systems that do like an automated check on these things. You have a few rules, you verify it and run it in a secure enclave, to make sure that the transaction is below this value. It's probably sent to this address before, and a few other checks, and then it's automatically verified if it's, let's say, 0.1, $10,000 or something like that below that value.
Yeah, just like the difference between a transaction at the local supermarket where you use your debit card versus wire transfer when you're buying a house, where you hope there's higher levels of security around it.
Yeah, it's like if you think about the card, sometimes you have to enter your PIN and sometimes it's below a value and it just runs through, So.
Let's talk about AI and how this is impacting your world. It seems to me like AI, even the arena of deep fakes, like the solution's got to be cryptography, right? We already know how to provide the integrity and confidentiality with cryptography. So why not wider use of HSMs?
AI is really something we study a lot because the whole world is turning towards AI, So, and the thing that we are concerned with, or we really look thoroughly at, is we're gonna have AI and AI agents gonna do stuff for us. They do stuff. They access systems. They're probably not going to just access the systems. They might actually modify stuff. They might buy things for us. And so the one thing is we need some authorization for that. And another thing is also we have to think about attestation and also creating a trail what the thing did, And this is attestation. What we're, for example, looking at is so who gave the AI the request to do something, what was the input on it, what model was run, to kind of figure out was the model already tainted at that point, what was the outcome, when was it run, and so you have an audit trail and can actually figure out what happened, because if it's good, nobody cares. If there is a problem, everybody wants to know what was going on, what happened, and why did it happen, and so on. And if you have an audit trail, you're all secure and can figure out what's going on and fix it for the future.
Amazing that a technology that's HSMs has been around for well over 30 years still has so much relevance to each new area of technology as it comes about. We've talked about cloud, we've talked about AI, and post-quantum. So, Robert, if you had to summarize one key takeaway from this podcast for CISOs, CTOs, CIOs, other IT decision makers out there, what would it be and why?
In your enterprise, in your systems, you have a lot of stuff that's running there and a lot of stuff that does encryption, does digital signature. And I think you need to kind of figure out how to control this, how to know what is happening, what actually are all the keys that we're using, what are all the certificates that we're using. We have already certificate systems in some systems because it's vital to your enterprise, but there are many more keys and more systems. So you have to figure out how to have a good key management system, how to really make sure that these keys are fully secured, in an HSM and not just somewhere in software. That's the trouble with a lot of things we see. It's just somewhere in a file system, which is not as secure as like this hardware vault that we provide from Securosys with HSMs. So think about that and think about how you're going to move to post-quantum, because this is going to take more time than the last transition from SHA-1 to SHA-2.
For sure. Thank you so much for joining us today, Robert. That was a great discussion on HSMs and how to best protect your encryption keys and Securosys' patented multi-authorization system.
Thank you.
And thanks to everyone who's listening. We hope you take a lot away from today's podcast. For further information on HSMs, please head over to securosys.com. That's with a Y. We'll be back next week with another episode in our podcast series. Until then, make sure you subscribe to this podcast on all major platforms and follow the conversation on our socials at EM360Tech on Twitter and LinkedIn. And for more great daily content, head over to em360tech.com.